basically Olympiad season is over, but just to troll us, Chem Olympiad still exists. God dang it, Chem Olympiad, why can't you just be a little earlier so I can relax now? Come on. Hello everybody, I'm Carl, and today we're going to be doing the 2018 USNCO open exam. But because Chem had all these nasty periodic table nonsense, we're going to have to do a very complicated setup. Look at this, look at this nonsense. You got like questions on the top, periodic table on the bottom left, and then on the right you got your screen. Now I'm really confused because like on the test it says suggested time 1 hour 10 minutes, which is like way too much time. Wait, hold up. It's wait, 110 minutes. Whoa, holy. That is 1 hour and 50 minutes. That is like way too much, honestly. I don't know. And it says suggested time. What does that even mean? Well, whatever. It's fine. So basically, like, the time is usually not the main constraint for this Olympiad. So basically what I'm going to do is I'm just going to run a stopwatch in the background and we'll see how long it takes. And also because it's such a thick test, 60 questions. Who wants to do 60 questions in one sitting? I'm just basically going to be just doing the first 20 right now and then we'll split it up into 3. Epic. So today, we're going to be doing the 2018 open exam. Enjoy! Alright, we're going to start off with some boring stoichiometry nonsense. So, we basically start with 225 grams, then you multiply by 32 grams per mole, and then you multiply by 6.02, hopefully I don't mess up, 6.02 times 10 to the 23, add a molecule, bruh. Okay, you get the idea. Molecules per mole. And then we basically get something. Okay, how am I going to do calculator stuff? Should I just use my phone? No, but I need to show you what I'm calculating. Okay, we're just going to do a new tab whenever we calculate. So 225, I forgot my stop. Bro, I forgot my stopwatch. Let's do stopwatch. Alright, we're going to start the time and then we're going to do calculating. So 225 over 32 times 6.02 times 10 to the 23. And then we have to multiply by 2 because in each molecule of oxygen you have 2 atoms. So that's going to give you 8.5 or 8.47. Let's see what it is. 8.47, so C. Very epic. Alright, now we get some epic solution stuff. So we got 0.3 solution, molar solution of HCl, prepared by adding some 1.5 molar HCl to a, I can't read, okay, to a 500 milliliter volumetric flask and diluting it with deionized water. Okay. What volume of 1.5? Okay, so I see. So basically, you want the number of moles of the acid to be the same. So basically, you have 0.3 times the volume, which is going to give you 0.5 liters, is equal to 1.5 molar times the volume that we want. Okay, so we just do this. 0.3 times 0.5 over 1.5 is 0.1. V is equal to 100 milliliters. So our answer is A. Okay. 3. Copper 1 oxide, Cu2O, is reduced by metallic copper by heating in a stream of hydrogen gas. What mass of water? Okay, so we just gotta write the equation first. That is the first step to all the chem questions. Just write an equation, do stoichiometry, blah blah blah. So I used to think that stoichiometry was the coolest word ever, but now I'm just sick of it. God dang. How our minds are corrupted. And then this is just gonna give you Cu plus H2O. And with that balance, then we get 2Cu. Okay, so if you have 10 grams of copper, then you gotta divide by the molar mass of copper, which on our periodic table is 63.55 grams per mole, and then it's a 2-to-1 ratio with water, right? Yeah, 2-to-1 ratio with water, so times 1/2, and then we got to wait, how much do you want grams? Yeah, 1 gram. So we multiply by the number of grams of H2O, which is 18.0 grams per mole. And then everything should cancel out and leave us with grams, and we get 10.0 divided by 63.55 times 18 over 2 is 1.42. You get 1.417, which is B4. So the mineral NR is 48.41% copper, 19.02% astatine. Arsenic. I'm trolling. Yeah, arsenic. Bruh. And 32.57% sulfur by mass. So basically what you gotta do is you gotta assume that there's 100 grams, so that means there's gonna be 48.41 grams of copper, and then if we convert this into moles, we get, 63.55, and then this gives us 48.41 over 63.55 is gonna give us 0.76 moles of copper. Okay, and then we wanna do, arsenic. So we basically had 19.02. What is the, okay, so over here, 33 on the periodic table, 74.92. and we plug that in, 19.02 over 74.92 is going to be 0.25. 0.25 moles arsenic. Okay. And then we got to do sulfur, so 32.57 times 1 over sulfur, which should be like 32, right? Yeah, 32.07. And then that's just going to be, probably just 1, right? 32.57 over 32.07. Yeah, just 1.01, we could say. 1.01 sulfur. So now, basically what you do to find the, well, we could basically approximate it. So it's 1 to 3 to 4 ratio, so it's going to be Cu4, wait, what? Cu3AsS4. Okay, nice, C. 5, let's do it. Okay, 5 grams of a sample of calcium nitrate contaminated with silica is found to contain 1 gram calcium. That's how you say it. I don't know how to pronounce stuff. Okay, what is the mass percent purity of calcium nitrate in the sample? Okay, so let's first find out the mass of calcium in the 5 gram sample, and then, wait, what? Oh, the sample is so the 5 grams includes the contamination. Wait, this is not that straightforward, is it? Oh, okay, so let's just say that X is a mass percent, right? X is, oh, let's not say mass percent, let's say moles percent. Is that better? Actually, we can just say mass percent. Okay, so that means that 5X is going to be the mass of the calcium nitrate, and then if we want to find the mass of calcium, we basically multiply by the mass percent of calcium and calcium nitrate. So calcium is what? 40.1, and then over the total mass, which is 40.1 plus 2 times n, which is 28, plus 6 times 16, which is 96, and then this is equal to 1. So if we just multiply this out, it should work. 1 times 40.1 plus 28 plus 96 over 40.1 over 5. So we get 82%. X is equal to 82%. Nice. So D it is. Okay. A solution of 20 grams of which hydrated salt dissolved in 2 grams of H2O will have the lowest freezing point. So basically the way it works is like the formula is IKFM. IKFM. Wait, how do you do hydrated salt? Oh, so basically I is going to be 2 for all the binary salts. Like they split into, it's the number of ions they split up into. So CuSO4 splits into Cu plus and SO4 minus. Wait, what? Oh yeah, Cu2 plus and SO4 2 minus, yeah. And then Kf is a constant for water, and then M is going to be based on the molar mass. So the molarity is inversely proportional to the molar mass because it's basically moles over mass of solvent, and mass of solvent is constant. So it basically, and if you have more molar mass, you have less moles. So if you have less moles in the numerator, then your M is going to be less. So basically, if I is 2, then we want to have the highest molar mass, or no, lowest molar mass. So we would take C, but it might not, but then we had to check whether it's better than D. It's proportional to I and inversely proportional to M. So what is 2 over 246 is 0.008, and then the other one was 3 over what? 3 over 286. So this is quite clearly bigger. Well, not quite clearly, it's a little bit bigger, so it's going to be D. So just to explain myself a little bit more, IKFM is the amount that your freezing point decreases or your boiling point increases. And basically for Na2SO4, I is equal to 3, and then, as I said, it's inversely proportional to your molar mass. So we just have to find the ratio between I and molar mass, and whichever one has the highest one is going to have the most depression in their freezing point. Okay, 7. Addition of 6 molar HCl to which substance will not result in gas evolution? God dang it, I feel like I'm going to miss this one for some reason. So it basically has to be a very unreactive thing. Okay, so C is for sure going to give a gaseous product because basically when you react with K2CO3, it becomes KCl and H2CO3. But H2CO3 breaks up into water and carbon dioxide is the gas. And then NaCl, oh wait, that might work. So the property of acids is that they always produce hydrogen gas when they react with a metal that's like more active than hydrogen. Oh, I need to review my activity series, god dang. But D does not seem like it would, yeah, there's like, oh wait, no. Wait, I need to remember if HNO3 dissolves, splits. I'm pretty sure it doesn't split. Yeah, so it should be D. Okay, it's D or A, which one is it? Okay, yeah, it should be D. Let's go with D. D it is. Alright, a divalent metal ion is dissolved in dilute hydrochloric acid and forms a precipitate when H2S is dissolved through the solution. So basically it precipitates with a sulfur ion. So it doesn't form precipitate with Cl, which is basically everything. What? Well, okay, Castrobear is a thing that doesn't work. Okay, it's probably gonna be calcium because I don't recognize any of the other ones. Rip. Okay, yeah, we're gonna go with calcium. Hey, wait, CAS is not soluble? I feel like it is. ZNS CDS. Yeah, basically calcium is an odd one out, so that should be fine. Okay, 9. Okay, so basically for this we just want to find a one with a transition metal with unpaired electrons. So the only transition metal is Mn, so I'm pretty sure it's just going to be A. Number 10. Okay, so contains 0.1 molar Sr2 plus ions and 0.1 Ag plus ions. Addition of an equal volume of 0.5 molar solution, of which reagent will call precipitating as a strontium salt, but not a silver salt. Wait, what? So AgNO3, wait, but strontium? Well, AgCl for sure, it will be a precipitate, so that's out of the picture. I'm like pretty sure AgNO3 is fine, but I'm pretty sure SrNO3 also works. So it's either C or B, and I'm pretty sure, I don't know anything about fluorine, so it's probably going to be C. Let's go with C. I know the strontium hydroxide is not soluble, so that should be fine. 11. Which would be most suitable for measuring 2.7 milliliters of ethanol for addition to a reaction with acidified chromate. Dichromate. Okay. So that's literally just going to be cylinder, because 2.7 is not like a exact measurement, or like you can't measure it with a 10 milliliter volumetric flask. And if, like, okay, volumetric stuff just doesn't work for this, and then beaker is just bad, so A should be the answer. Okay. Basically the way it works is volumetric only does its own volume. You can't get anything in between. Graduated cylinder is really good for in-between stuff, and then beaker is just bad. Okay, molar mass of solid carboxylic acid is determined by titrating a known mass of the acid with standardized solution of NaOH to, okay. Which of the following errors will lead to a molar mass that is smaller than the actual molar mass? Some of the acid is spilled. So basically, if you get a smaller molar mass, that means that you thought that you need too much. Wait, what? Okay, so the smaller molar mass that you got, that means you expected more moles of acid. So that means it was harder to titrate it. Okay, than it should have been. So this would make you get a higher molar mass because it would be so easy to titrate it, which means that you would expect less moles of acid, which means higher molar mass. So 1 is not right. And then if the endpoint, yeah, okay, so if this is true, that means you added so much extra stuff than you needed to, and that means you thought it was a lot harder to neutralize it, which means you thought there was more moles of acid, which means you thought there was a lower molar mass. So that's why it's going to be only 2. Okay. 13. Gas? Is it not? Yeah, it's like for sure gas. Wait, yeah, there's literally no way, right? Because they're not, yeah, okay, gas, okay, sure. If I'm wrong on that one, I'm going to be so sad. The normal boiling point of 2-propanol is 83 degrees Celsius, while that of acetone is CH32CO 56 degrees. What is the principle? Okay. So propanol has a hydrogen bond here. Okay, that's it, right? Yeah, literally it is. The reason not A, because the bond itself isn't stronger, it just, like, the intermolecular forces are more. Okay, so increasing molecular speed means decreasing molar mass. So CCl4 is massive, CO2 is next massive, and then N2 is like relatively small, and then He is the smallest. So increasing, we want to go from biggest to smallest. So 3, 1, 2, 4. Okay. Yeah, this. Okay, B. Bro, why are there so many conceptual questions? God dang it. Okay, so high temperature I know, and low pressure. Because basically at high temperature, they're moving so fast that intermolecular forces don't play an object, and the only thing that matters really is collisions between the molecules. The reason why it's low pressure is because then they're more spread out, and then intermolecular forces don't matter as much. So it's basically going to be 1 only, A. 17. Solvent has a melting point of 1710 degrees Celsius, soluble in water, and does not conduct electricity in a solid state. So it seems like the melting point is pretty high, so it's probably not molecular. It's soluble in water, but does not. So ionic literally just sounds like. Because ionic has the strongest intermolecular forces other than network covalent. But network covalent does not dissolve in water, and metallic conducts electricity in solid state, so it's probably just C. Okay. 18, let's go. Okay. Toluene has both a higher vapor pressure than water at 25 degrees Celsius and a higher normal boiling point. So it's like not, it doesn't have any intermolecular forces other than like London dispersion. So higher molar mass does mean higher normal boiling point. Wait, what? Actually, that's weird. Because if you have higher vapor pressure, then doesn't that mean... Oh, yeah, so it's probably C then, right? Wait, what does that have to do with it? Well, basically, the reason why I'm confused is because, like, higher pressure, vapor pressure means that the molecules want to leave more, right? Wait, also if density is higher, then doesn't that mean that pressure is lower? So that's not good. So that one, yeah, so it has to be C. There's no other option. And that also kind of makes sense, because that means you need more temperature in order to, like, actually evaporate the thing. Wait, no, but how did that matter? Wait, lower heat of vaporization? Hold up. That means it would go really fast. Wait, no, then it literally has to be D, because all the other ones just don't make sense. Because molar mass has nothing to do with it. Okay, it's really just going to be D then. Okay, D it is. 19. To 100 grams of water at 25 degrees Celsius in a well-insulated container is added a block of... Dang, that's some fancy grammar we got there. Is added a block of aluminum initially at 100 degrees Celsius. The temperature of the water once the system reaches thermal equilibrium is 20. Okay, this is easy peasy lemon squeezy. Okay. So, basically, you had to set the heats equal. And you basically use MC delta T. So, 100 times C of water, which is just going to be 4.18. Yeah. And then you had to multiply that by delta T, which is 3, since it goes from 25 to 28. And then is equal to mass of this times its heat capacity times the amount of change, which is like 75. Oh no, 72. Okay, so then if we just divide stuff, 100 times 4.18 times 3 over 0.9 over 72 is equal to 19. M is equal to 19.35. Okay. Wait, right? I didn't troll. Okay, 19.35. So C. And 20. Last but not least, 20. Let's see. Yucky. Okay. So basically, standard enthalpy of formation is per mole of MgO. So on the right side, you want to have 1 MgO. You also want to have everything in the standard forms. So O2 is standard. This is standard for O2. None of these are standard, so it's just A. Okay. And let us check our answers. I think there's like 3 in the middle that I just scrolled on. So let's see. Okay, should we just check it first? 7, 8. Okay, I just don't know how to do these ones. Okay, this one I'm pretty sure about. This should be fine. And then this one? Okay, yeah, I'm pretty sure it should be D. Okay. And then this one I just have no idea. But, well, should be good. Also, why did I get 5, 6, 7, D? Whatever. That should be fine. Should be fine. Okay, let's check. Oh, it's at the end. Okay. Let's do this. Okay. C, A, B, C. Rip 8 was D. God dang it. And then 10. Okay, how did I miss 10? 11. A, B, A, D, B, A, C. No, how did I miss 18? Bruh, this is so bad. How many did I miss? 3? 20 is A, okay. How did I miss 3? No, this is not okay. 3 in the first 20 is pretty bad, not gonna lie. But let us see. Okay, 8 I knew I was gonna miss, that's fine. 10. Okay, but yeah, also I knew I was gonna miss that one, honestly. Okay, so 18. Hold up. Okay, well, okay, we figured, okay, so, bruh. But somehow I thought that all of them, okay, so A is for sure not right. Because higher vapor pressure usually have lower boiling point. B, I feel like, why did that matter? Because if you have higher molar mass, won't you have less vapor pressure? So, lower heat of vaporization. I think the answer was lower heat of vaporization, right? Yeah, why did that make sense? I just thought none of this made sense. Okay, let's see. Lower heat of vaporization? Why does... Wait, let me do another thing. Why does lower heat of vaporization mean higher boiling point? Okay, so this should tell us... What? What does that have to do with boiling point? Okay, why does toluene have a high boiling point? Wait, what? No, it's not because it's a big molecule. Wait, what? Reddit, very, very critical source. Oh. So normal boiling point is at 760. Okay. But why did that... What did that have to do with the latent heat? Bro, none of these are actually useful. Well, honestly, you could do this one with system of elimination, but what? Oh, maybe? Okay, I think I get it. So, basically, I think it's like... Alright, so what I got is basically, like, you see this curve? This is like the vapor pressure and this is the temperature, right? So at 25 degrees Celsius, benzene is D, so it's green, so it does have a higher vapor pressure. But normal boiling point is up here. So see the cross over here? I think it's because if you have a lower latent heat, your curve is going to be more flat. Because that means, like, even at low temperatures, you're going to have a lot of pressure, but as you go higher, it doesn't increase by that much. So eventually these curves just cross, and that's why it makes sense. Okay, that makes sense, but I don't know how I'm supposed to know that. What the heck? Okay, fine. Okay, let's look at 10 and 8. Okay, so 8. Precipitates with sulfur. Nope, not what I wanted. Chemistry. Wait, I think it's full screen. We don't need this anymore. Okay. How do you precipitate sulfur? Wait, what? Didn't I put calcium? It's not? Okay, wait. Form precipitates with sulfur. Okay, I guess it's just something you know. Why is cadmium sulfide insoluble? Yes. Let's see. Sulfur solubility rules. Oh my god. Oh, I just forgot my rules. Okay, so basically everything is not soluble except the things that are. Wait, what? Hold up. Sulfides. So alkaline, okay. Wait, what? Then why did the other ones? What? Why don't these guys work? But it does precipitate. Okay. Whatever, I'm confused. It's fine. Let's see. Can we figure out this one? So we know it's not this. We know it's not this. So is it B then? God dang it, it's B. We took a 50-50 and we didn't. Okay, let's see. Fluorine. Oh, they're considered slightly soluble, so that won't work. Okay, so I guess you just do it by elimination again. Okay, whatever. Triggered. Whatever, it's fine. We got a 17 out of 20, which is pretty trash, not gonna lie. Well, honestly, it doesn't increase in difficulty. So if I continue this streak, it would be 3 times 3, so it would be 21 out of... No, sorry. 51 out of 60, which is not bad at all. And how much of a stopwatch are you running at? Okay, straight up, I didn't even stop it before we started looking at the answers. And even if you multiply this by 3, it's still less than 110 minutes. So honestly, time is literally not a constraint, so it should be fine. You can probably look at my clock down here to tell me how long it took. It was a lot less than 30 minutes. It was like 20 minutes maybe, max. Alrighty, that's all I got. As always, if you enjoyed the video, leave a like and subscribe for more. Thank you guys for watching again, and see you guys next time.